Welcome back all of you to our online platform, that is our school's YouTube channel. So again we are ready with today's video. This video is for class 9th and the subject is science, and we are continuing the same chapter, that is chapter number 8, and the name of the chapter is motion. So as we are discussing the questions given within the chapter, means in text questions, and yesterday we have discussed the questions given on the page number 102, 3 or 7. So today we will continue the chapter, the questions given within the chapter. So on page number 107, question number 1. Question number 1 is given. In that, the question is like that: what is the nature of distance time graph for uniform motion and non-uniform motion? So the distance time graph will be like that. And on the vertical side we will show the distance, and on the horizontal side we will show the time, because this is the distance time graph. Now we are supposed to show the graph for the uniform motion, and this is for non-uniform motion. For the uniform motion, I told you that the distance time graph, we will have a straight line. If a straight line is there, then we can say that the object is under uniform motion. Or if any curve is there, if a straight line is there, then uniform motion, and if curve is there, then it will be non-uniform motion. In this graph, the curve cannot go downwards, curve will always go upside only, because the distance cannot be negative, and these are the distance time graph, not the displacement time graph. So this is the answer for question number 1 on page number 107. Now question number 2. So what do you say after observing the graph given below? The distance time graph is given in question number 2. In question number 2, the distance time graph is given. Question number 2, and in that distance time graph, this is like the line parallel to time axis. We have already discussed that if in distance time graph a line is shown parallel to the time axis, then we will say that object is at rest. This graph shows that object is not under motion, it is at rest, because the position in the starting is here, and at the end it is same here. So distance is same. So we can say that this graph shows that the object is at rest. At the same time, if this graph is graph is there in question number 3, and we have changed the distance time graph to the speed time graph or velocity time graph. So, and the same thing is given there. In speed time graph, if the line is parallel to time axis, then we will say that the object shown in this graph is under uniform motion, or we can say the object is moving with constant speed. So these are question number 1, 2 and 3. Now we will proceed towards the question number 4. In question number 4, it is given that what is the quantity measured by the area under VT graph. VT means velocity time graph. Suppose this is VT graph, and this is question number 4. So area under the VT graph means this area. Suppose this is the question. So area under this graph is in the rectangular form. The area under the VT graph shows the distance covered. Area under VT graph shows or represents the distance covered. We can verify from here. This is a rectangle and this is velocity and this is time. So area of the rectangle is equals to velocity into time, or speed into time. Speed into time is equals to distance, we all know. So this is the question of this is the answer of question number 4 given on page number 107. Now we move further on page number 109. On page number 109, the numerical is given as a question number 1, and the statement of the question is: a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Then we are supposed to find the speed attained or speed acquired, or in the second part we have to find the distance covered. A bus is starting from rest. If anything is starting from rest, then the initial velocity will be 0 and the acceleration is there, that is 0.1 meter per second square, and the speed will be in meter per second. Then the time is also given. Time is 2 minutes. So we are supposed to convert 2 minutes into seconds. 2 into 60, that is 120 seconds. Now we are supposed to find first the velocity, and in second part we are supposed to find the distance. So we are having 3 equations of motion, and according to first equation of motion, we know what we know, that V is equals to U plus A T. V we have to calculate. U is given here, A is given here, T is given here. So we can use that equation. So V is equals to U is 0 plus 0.1 into T. T is 120 seconds, and from here we get V is equals to 0.1 into 120, that is 12 meter per second. So the bus will acquire the speed of 12 meter per second after 2 minutes. At the same time, we have to find the distance covered during this time. So for that we can use the second equation of motion, that is S is equals to ut plus half at square. So S we have to find, U is 0, 0 into 120 plus half into A is 0.1 and T is 120. So from here S, this becomes 0 and this is 1 by 2. 0.1 we can write 1 upon 10 into 120. A T square means 120 square means into 120. So 1 0 cancel out, 1 0, 2, 6 is 12 and the S will be 6 into 120, that will be 720 and the answer will be in the SI units only, means 720 meters. So according to this question, the bus has acquired the speed of 12 meter per second after 2 minutes and the distance covered during this time, the given time, is 720 meters. So like this you are supposed to proceed the questions, either these are the theoretical one or the numerical one within the text, within the textbook. And I hope that now you can solve each and every question given on the page number 100, 102, 103 as well as 107 as well as on page number 109, and you are supposed to write the answers of all these questions in your rough notebook, and after writing the solution or answers of this question, you are supposed to take the pic of that and you are supposed to upload on the school's WhatsApp number. If you face any problem and or you are having any kind of doubt, then you can message us or you can even call us. We will try to resolve your doubts so that you can easily proceed the questions given in your textbook. Thank you very much.